Section 5.5, Multiplication of Polynomials. To multiply polynomials, multiply the coefficients, multiply the variables using the product rule of exponents. So we have 3x to the fourth times negative 2x squared. We know that when we're multiplying, it doesn't matter the order in which we multiply. So we could think of this as 3 times negative 2. Let's put the numbers together. And x to the fourth times x squared. 3 times negative 2 is negative 6. X to the fourth times x squared. What do you do with those exponents? You add them. So our final answer is negative 6x to the sixth. A negative times a negative here gives us a positive answer. Negative 5 times negative 1 is just positive 5. X to the ninth times x to the first, add those exponents, x to the 10th. We want to multiply the coefficients. 4 times 3 gives us 12. X to the, we have the fifth, the second, and the sixth. You want to add those. 5 plus 2 plus 6, 13. X to the 13th. You want to multiply the coefficients. Negative 2 times negative 3 is positive 6 times 10, 60. A to the second times a to the third times a. You want to add the exponents. 2 plus 3 plus 1, 6. A to the sixth. B to the first, b to the fourth, b to the sixth. Add those exponents. B to the 11th. How do you square or cube something? Well, we have a rule that says when you have exponents outside the parentheses, they apply to all the factors inside the parentheses. And if there is already an exponent inside the parenthesis, you multiply them. So that gives us negative 8, m to the 12th, n to the third. Find the square of 10 x to the fourth y. Let's square that. 10 squared, x to the fourth squared, and y squared. 100 x to the eighth y squared. How do you multiply a monomial times a polynomial? You just use the distributive property. So 3x times 4x is 12x squared, minus 3x times minus 5 is minus 15x. Negative 4x cubed times 2x to the fourth is negative 8x to the seventh. Negative 4x cubed times negative 3x squared is plus 12x to the fifth. You add those exponents. Negative 4x cubed times negative x is plus 4x to the fourth. And negative 4x cubed times plus 5 is minus 20x to the third. That's it. Now we can multiply times a monomial, but it doesn't matter whether that monomial is at the beginning or the end. You still do the same thing. You use the distributive property. You multiply that minus 2x squared times all three terms in this trinomial. So you have negative 6x to the fourth plus 4x x to the third plus 2x squared. And that's it. That's all you can do. Oh my goodness, what a monstrosity. We want to multiply here, here, and here. 5 times negative 3 is negative 15. X cubed times x squared is x to the fifth. Y times y to the fourth is y to the fifth. Because it's y to the first times y to the fourth, and you want to add those exponents. Plus 20, x to the fourth, y to the eighth, minus 30, x to the sixth, y. And that's your answer. Let's simplify these. Now be careful. You're multiplying the 3x squared minus 4x minus 1 times this monomial of 2x squared. So you're going to distribute this multiplication times all three terms in this trinomial. But it does not apply to that minus 2x cubed at the end. Leave it alone. But you will have 6x to the fourth minus 8x cubed minus 2x squared. Now, at this point, there is something else you can do because you have like terms. Your 6x to the fourth is your highest degree term, minus 8x cubed minus 2x cubed, minus 10x cubed, minus 2x squared. Now, that's your final answer. Look at this. You have to multiply by a monomial. First by 3x, you have 3x cubed minus 6x squared minus 15x minus 10x cubed plus 15x. Look for your like terms. Minus 7x cubed minus 6x squared. What happens with that? Minus 15x plus 15x. It's 0. So that's all there is. Lots of powers here. Multiply this binomial by minus 4ab squared. That's minus 8a cubed b to the fifth plus 12a squared b to the third minus 5a squared b third plus 3a cubed b to the fifth. Do we have any like terms? I see a cubed b to the fifth. Minus 8 of them plus 3 of them minus 5 of them. What about these? A squared b cubed plus 7 a squared b cubed. And that's our answer. Next problem. Let's multiply by 3x squared. We have to multiply both terms by 3x squared. 6x cubed minus 12x squared y. Now let's multiply both terms here by 6x. We have to be very careful with these signs though. I'm going to leave that minus sign outside the parentheses and deal with the 6x first. That gives us 18x cubed minus 6x squared y. Now think what that minus sign does. Minus 18x cubed plus 6x squared y. So we have 6x cubed minus 12x squared y minus 18x cubed plus 6x squared y. Like terms, minus 12x cubed, x squared y, minus 6x squared y. How do you multiply two binomials? Well, you can think about the distributive property if you want. You could distribute this times that and times that. So that would give you x plus 2 times x plus x plus 2 times 3. That gives us x squared plus 2x plus 3x plus 6. A lot of times you learn this as the FOIL method. First, outside, inside, last. You multiply the first term in each set of parentheses, a times c. You multiply the outside term in each set of parentheses. That gives you a times d. This is first. This is outside. You multiply the last terms in each set of parentheses. That gives you b times d. I skipped over the inside. The inside terms in each set of parentheses. That gives you b times c. FOIL, first outside, inside, last. So let's do this with FOIL. First, 2x squared. Outside, plus 8x. Inside, minus 5x. Last, minus 20. Outside and inside are like terms. Let's combine them. 2x squared plus 3x minus 20. That's it. That's our answer. FOIL is just a nice way to remember the pattern to ensure that everything gets multiplied sooner or later. 3x times 2x minus 15x minus 8x plus 20. And a lot of times the outside and the inside are like terms. Combine them, and you have your final answer. You can have different powers of x. You still do it the same way. If it's a binomial times a binomial, first, 2x to the 4th. Outside, 3x cubed. Inside, plus 2x. Last, plus 3. There's no like terms this time, so you're through. No like terms, you have to leave it alone. First, 21a squared outside plus 28ab inside minus 6ab last minus 8b squared. Like terms, 21a squared plus 22ab minus 8b squared. That's our answer. First, 12y. Outside, minus 27. Inside, minus 20. y squared. Last plus 45y. Our inside and our outside aren't the like terms. It's our first and our last. Those are like terms. Let's write this in standard form. Let's put it negative 20y squared, descending powers of y. Then we'll have 12y plus 45y, 57y, and finally minus 27. How do you square something? You write it down twice, and you FOIL it. First, 9x squared. Outside, minus 6x. Inside, minus 6x. Last, plus 4. 9x squared minus 12x plus 4. That's our answer. How do you square something? You write it down twice and you multiply. Oh my goodness, how do you multiply a binomial times a trinomial? There are two methods that I can think of. The first is kind of, I like to call it the spaghetti method. You have to multiply each term in the first polynomial times each term in the second polynomial. I call this the spaghetti method because it looks like spaghetti. I personally like to do it vertically. I take the x squared minus 4x plus 5. I like to take the one with the most terms and put it on top, the 2x plus 3 underneath it, and I like to multiply vertically. Now if you had a number, for instance if you had 123 times 21, you would start with a 1 and you would say 1 times 3 is 3, 1 times 2 is 2, 1 times 1 is 1. You do the same thing here. You start with a 3, you multiply it times 5, you get 15. 3 times negative 4x is negative 12x. And then 3 times x squared. Back with our number example, after you get through multiplying everything by 1, you multiply everything by 2. 2 times 3 is 6. You move over 1 because you're in the tens now. 2 times 2 is 4. And 2 times 1 is 2. Then you add 3, 8, 5, 2. It's easy with numbers. You've been doing that a long time. You do the same thing with the variables. We multiplied everything by 3. Now we go back and we pick up the 2x. 2x times 5 is 10x. That's a like term. We move over 1. That's a like term with minus 12x. 2x times minus 4x is minus 8x squared. And 2x times x squared is 2x cubed. Notice that all the terms are like terms are lined up. 2x cubed minus 5x squared minus 2x plus 15. And that's our answer. Now you can get the same answer with the spaghetti method, and I have students who always want to use the spaghetti method. But you have to remember to multiply every term in the first polynomial times every term in the second polynomial, and then you have to remember which ones are like terms. I like the vertical method because you have a system to multiplying everything and you line up the like terms as you go. But it's up to you. Choose the one that works for you. Oh my goodness, your spaghetti method, you're going to have to multiply each term in the first polynomial times each term in the second polynomial. It's really spaghetti this time. Let's try the vertical method. So we have x squared plus 3x minus 7. It doesn't matter which one goes on top. X squared minus 2x minus 5. Let's try to multiply these guys. Minus 5 times minus 7 is plus 35. Minus 5 times 3x is minus 15x. And then minus 5x squared. Next, we take our minus 2x and multiply it times everything in the top row. Minus 2x times minus 7 is plus 14x. Minus 2x times plus 3 is minus 6x squared. Minus 2x times x squared is minus 2x cubed. Do you see how our like terms are lining up? Now we use the x squared. X squared times minus 7 is minus 7x squared. X squared times 3x is 3x cubed. And x squared times x squared is x to the 4th. We have 35. We have minus x. We have minus 18x squared. And we have x cubed and x to the 4th. And that's our answer. I like that vertical method. It makes it easy to keep up with what you have to multiply, and it helps you to line up those like terms. That's all for this section.